In this video, we will learn about resistors in parallel. So how are resistors connected in parallel? In a parallel arrangement, one end of all the individual resistors is joined at one point and the other end of all the individual resistors is joined at another point. So let me draw three resistors connected in parallel. This is resistor 1, this is resistor 2 and this is resistor 3. One end of all the resistors is joined at end A and the other end of all the resistors is joined at another point B. This is resistor R1, this is resistor R2 and this is resistor R3. Now in a parallel grouping of resistors, potential difference across each resistor is same and is equal to the potential difference across the parallel combination. So let us say potential difference across R1 is V1, across R2 is V2 and across R3 is V3. So in a parallel combination, potential difference across each resistor is equal and is equal to the potential difference across the combination, that is potential difference across the points A and B. Now moving on, in a parallel combination of resistors, total current I in the circuit is equal to the sum of the separate currents through each branch, that is each resistor of the combination. So let us suppose in this branch the current is I1, in this branch the current is I2 and in this branch the current is I3 and the total current in the circuit is I. So I will be equal to I1 plus I2 plus I3, that is the sum of the separate currents through each branch. Let us now find the expression for equivalent resistance in case of parallel combination. So we are taking three resistors R1, R2 and R3 which are joined in parallel combination. They are connected to a battery of voltage V and a current I is flowing in the circuit. The current is divided into three parts. The current in branch 1 is I1, the current in branch 2 is I2 and the current in branch 3 is I3. The potential difference in case of a parallel combination is same across all the resistors and is equal to, this case is V, that is the battery voltage. So this is the given situation. So now as per Ohm's law, we know that V is equal to IR and we can rearrange this formula to write it as I is equal to V divided by R, that is current is equal to potential difference divided by resistance. So from this we can find out the current flowing through the individual resistors. So I1 comes out to be V by R1. Similarly, I2 is equal to V by R2 and I3 is equal to V by R3. Now we know that in case of a parallel combination, the total current in the circuit is equal to the sum of currents flowing through each branch. So I is equal to I1 plus I2 plus I3 and I1 is V by R1, I2 is V by R2 and I3 is V by R3. Now before moving on, let us discuss what is an equivalent resistance. So equivalent resistance, to understand it, let us suppose I replace these three resistors R1, R2 and R3 with a single resistor. I am drawing the circuit again and I am replacing these three resistors R1, R2 and R3 with a single resistor of resistance Rp, and this resistance is called equivalent resistance. So this is the circuit, the battery voltage is V and the current flowing in this circuit is I. So the potential difference across this equivalent resistor is the potential difference or the voltage of the battery. So this is the equivalent circuit of this parallel combination. So now if you suppose Rp is the equivalent resistance of the combination, the total current in the circuit will be I is equal to V divided by Rp. Now if we compare both these equations, that is I is equal to V by Rp and I is equal to V by R1 plus V by R2 plus V by R3, we will get V by Rp is equal to V by R1 plus V by R2 plus V by R3. We will cancel V from both the sides like this. So finally we will get 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So thus in case of a parallel combination of resistors, the sum of reciprocals of individual resistances is equal to the reciprocal of equivalent resistance of the combination. Now we will discuss some points for parallel combination of resistors. The first point is the potential difference across each resistor is exactly the same and is equal to the potential difference across the combination. So this point we have discussed already. The next point is the total current through the parallel combination of resistors is equal to the sum of the individual currents through various resistors. So the current I will be equal to the sum of the currents through each branch, that is I is equal to I1 plus I2 plus I3. The next point is the expression of equivalent resistance in case of parallel combination, that is the sum of reciprocal of individual resistances is equal to the reciprocal of the equivalent resistance of the parallel combination, that is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 and so on, depending upon the number of resistors joined in parallel. Now the fourth point is important. The equivalent resistance of the parallel combination is lesser than any individual resistance used in the circuit. So let us suppose there are three resistances R1, R2 and R3 joined in parallel. So the equivalent resistance of these combination, let us suppose, is Rp. So Rp will be less than R1 and it will also be less than R2 as well as R3. This point says this. Now moving on to the next point. If n resistors, each of resistance R, are joined in parallel, then the equivalent resistance of the combination is given by Rp is equal to R divided by n. So if n resistors are joined in parallel and each resistance is R, so the formula for equivalent resistance is 1 by Rp equal to 1 by R plus 1 by R plus 1 by R, and this will continue till n times. So 1 by Rp will be n multiplied by 1 by R. So from this Rp comes out to be R divided by n. Now the sixth point is, if two resistances R1 and R2 are joined in parallel, then the equivalent resistance Rp is given as, so from here we can rearrange it and write Rp as R1 R2 divided by R1 plus R2. Now the last point is, resistors are connected in parallel if the effective resistance of a circuit is to be decreased. So in parallel combination, the equivalent resistance is decreased. Let us now discuss some advantages of parallel combination of resistors in electric circuits. The first advantage is, in the parallel arrangement, the equivalent resistance of the circuit is reduced, and if the resistance is reduced, we can say that there will be more current drawn from the power supply or the voltage supply. The second advantage is, in the parallel arrangement, the total circuit current is divided through various branches. Hence, each gadget draws appropriate current as per its operational requirement, although potential difference across each gadget is same. Thus, the method is especially useful when each gadget has a different resistance and requires different current to operate properly. The next advantage is, in the parallel arrangement, separate on-off switch can be employed with each gadget and we can use different gadgets as per our need. And the last advantage in parallel arrangement is, if one component of the circuit fails, then the other components continue to work. So let me explain point 3 and point 4 with the help of a circuit diagram. So in the first branch, there is a bulb and a switch like this. In the second and third branches also, there is a bulb and a switch as well, like this. So even if one switch is off, it will not affect the working of the other two bulbs. So this is the point 3, and in point 4 it says that even if one component fails, the other components will continue to work in case of parallel combination. I hope this topic is clear to you. Thank you.